My name is Faisal Hassan. I'm from West Tanzania, and this I have come with a new idea of a project that will help mankind, and it's called flexible zinc oxide nano generator. First, we start with the abstract. So, high-quality single zinc oxide nanowires were grown on silver and gold-coated plastic substrates. For the fabrication of a sandwich-like nano generator using the aqueous chemical growth method, the applicability of this configuration as a nano generator is demonstrated by studying the harvested electrical output under mechanical deformation. 3 different configurations were fabricated and utilized for harvesting piezoelectric potential by applying an external force. The maximum resulting output open circuit voltage and short circuit current were 2.4 volts and 152 volts. 152.2 volts respectively. The comparison between the different configurations indicates that more piezoelectric potential can be harvested by using 2 arrays of zinc oxide placed face to face than by using a single nano wire configuration. In addition, the use of a piezoelectric polymer will enhance the amount of generated piezoelectric potential. The obtained results from different configurations of zinc oxide nanowires generators offer a cost-effective, flexible, long-term, stable nano generator for promising application. The principle of the sandwich nano generator demonstrated a new idea for novel, self-powering nanotechnology that harvests electricity from the environment for applications such as portable electronics. Keywords. First, we start with the aqueous chemical. Then we follow by zinc oxide nanowires. And lastly, we finish by flexible sandwich nano generator. So, we go to the introduction. Today, the research community is trying to introduce personal electronic devices with self-powering capability or renewable sources of energy. Various clean energy and environmental friendly resources such as wind, solar, thermal and ambient mechanical energy, and etc. have been utilized for harvesting energy. Solar, wind and hydraulic resources are being used in many countries of the world, and even on an industrial basis as alternatives. Sources for harvesting electrical power 1 to 2. Nevertheless, harvesting from ambient mechanical sources still requires further optimization to maximize the output from a specific material, and at the same time provide a particular device that delivers energy solutions in a way that is easy to incorporate into a system. Therefore, different materials have been studied in order to fabricate optimized devices for harvesting a sufficient amount of piezoelectric potential from a suitable material. One important feature of an efficient piezoelectric harvesting system is that it should produce high output at low operating frequency. Zinc oxide is emerging as an attractive material for harvesting mechanical power, and as it is one of the best piezoelectric materials. In addition, zinc oxide is a semiconductor that possesses a direct band gap of 3.4 and a relatively high excitation binding energy of 60 MeV. Moreover, zinc oxide has a relatively large piezoelectric coefficient, high modulus of electricity, high piezoelectric tensor, and a high stable non-central symmetrical temperature. So we go to the methodology. In the laboratory of Zhenhong Ling Wang at Georgia Tech, a blinking LCD signals the success of a 5-year effort to conventional electronic devices using nanoscale generators. They harvest mechanical energy from the environment. Credit Georgia Tech by simplifying our design, making it more robust and integrating the contributions from many more nanowires. We have successfully boosted the output of a nano generator enough to drive these devices such as commercial liquid crystal displays, light emitting diodes, and laser diodes, said Wang. A Regents professor in Georgia Tech School of Materials Science and Engineering said, if we can sustain the rate of improvement, we will reach some true applications of healthcare devices, personal electronics, or monitoring, or environmental monitoring. Recent improvements in the nano generators including a simpler fabrication technique were reported online last week in the journal Nano Letters. Earlier papers in the same journal and in Nature Communication reported other advances for the work, which has been supported by the Defense Advanced Research Projects, DARPA, the U.S. Department of Energy, the U.S. Air Force, and the National Science Foundation. We are interested in very small devices that can be used in applications such as healthcare, environmental monitoring, and personal electronics, said Wang. How to power these devices is a critical issue. The earliest zinc oxide generators used arrays of nanowires grown on a rich substrate and topped with a metal electrode. Later versions embodied both ends of the nanowires in chromium and produced power by simple flexing. Regardless of the configuration, the devices required carefully growth of the nanowire arrays and painstaking assembly. In the latest paper, Wang and his group members Yu Fenghu and Yang Xinhang and Chen Su Gang Guangzhou and Zhengli reported on much simpler fabrication techniques. First, they grew arrays from a new type of nanowire that has a conical shape. These wires were cut from the growth substrate and placed it into an alcohol solution. The solution containing the nanowires was then dripped onto a thin metal electrode and a sheet of flexible chromium film. After the alcohol was allowed to dry, another layer was created. Multiple nanowire or chromium layers were built up into a kind of composite using a process that Wang believes would be scaled up to industrial production. We're going to the advantages of the flexible zinc oxide nano generator. The first advantage, it produces a lot of renewable energy, and the second is it's portable. So we're going to the disadvantages, which one is it's not environmental friendly due to the use of zinc, lithium, and etc. It is expensive, and conclusion. And the conclusion is that we have fabricated and stimulated the piezoelectric effect of zinc oxide, and we synthesize zinc oxide by a simple one-step step where we then have fabricated a novel flexible zinc oxide nanogenerator with a PNFP sandwich structure based on laterally aligned zinc oxide NF. The open circuit open output voltage and laterally aligned zinc oxide the open circuit output voltage and short circuit of this first prototype is up to 0.166 volts and 1.66 volts and 10 respectively. This nano generator is robust and has the potential to convert ambient mechanical energy to electrical energy. Thank you.